Okay, welcome back to Attack 404. In this episode, we're going to be taking a look at what we can do as far as attack and defense on wireless networks and how we can go about attacking a Wi-Fi network. So to put everything together and understand how everything works, we need to first understand how Wi-Fi authentication works. So I boiled this down into a very simplistic manner that you could research on your own if you like. So basically what happens is a Wi-Fi access point is set up. Everybody's excited. They want to connect. They want to get online. They want to look at YouTube and whatever the hell they're doing. So everybody connects. What happens is the Wi-Fi access point is going to ask you for an authentication process, and then an IV or initialization vector is going to be created during that handshake, and then the AP is going to say, you're friends of mine, let's get you online. So how exactly does the AP work? Break this down into some basics of how the AP operates and what information we use to connect. So we have the SSID, which is the Service Set Identifier, and that is the human-readable version of the BSSID, so to speak. So what happens is you make a Wi-Fi access point, name it Starbucks. Everybody sees that it's Starbucks, and then what ends up happening is they connect to Starbucks and they sip their coffee and they go online. The BSSID, or the Base Station Set Service Identifier, if I remember correctly, is in fact the physical address of the AP. Now this is going to play a very pivotal role in security and offensive security, because if you're only relying on the SSID, anybody could come on and within range of that network either knock it off, or they can spoof a greater signal than the SSID, and you'll have two Starbucks locations, but one is owned by an attacker and the other one is owned by Starbucks, and because the signal is stronger from the attacker, they will associate with the rogue AP. With bonus points, if the attacker has actually gone on and secured a faster wireless network, everyone's going to associate with that, and a man-in-the-middle attack can ensue. So when you do connect, what ends up happening is the encryption type is going to be presented to the endpoint. Say, hey, we're speaking this language, let's set up this type of encryption, and then we'll protect the communications back and forth. Finally, what you're going to see is the channel, and you're going to see the signal strength. This doesn't mean much, but it can kind of point to, during wireless assessments and walkthroughs, where an AP might be located by you walking to it or away from it. So the AP tells your attacker and other people in the area quite a few things about what is going on with that wireless network. The first is any associated endpoints. We can see any and all endpoints that are associated with your wireless access point. So if we need to start attacking that access point, we have systems that we can potentially pivot from. So with that, we could also see the MAC addresses of the associated endpoints. Now this is also another pivotal point, because with the MAC addresses, if in the event the user is filtering based on MAC address, what happens is we can spoof those MAC addresses back to the AP and basically present that we are that device. The other thing with this is, if you mask your SSID, during the course of scanning, we could uncloak that SSID with various techniques that we use, most notably booting people off and getting them back on the network. There stands the chance that your plain text SSID is going to be transmitted across the network. Not like that really matters if we have the BSSID, and which would be mostly what we'd be attacking anyway. So if you have a different type of method that you like to use or a secure setup to protect your AP, drop us a line in the comments and let us know. Now, how do we really crack Wi-Fi encryption, and what is at stake here? Well, there's multiple tools that we're probably going to take a look at. Of them is going to be the Aircrack suite with Kismet, and we'll probably pivot and take a look at WiFite. What ends up happening is you have endpoints that associate with your AP. And then this evil busted guy comes along and basically says he wants to be friends with your AP. In this instance, what's going to happen, what the attacker is going to see and look for, is the BSSID from what's being broadcast from the SSID, if that's available. If not, we will still see the BSSID. So from this point, we can see that there's two clients associated with this network, and of that, we can see the encryption algorithm that's used. So let's say we target the dude on the right. We enter a narcissistic relationship with this individual, and we tell him to get lost and come back. It's kind of like a love scheme, where you set someone up for failure, catfish them online, and then you block them and unblock them, you get money for it. But in this case, the money is actually the handshake that we're after, because we want that initialization vector packet so that we can crack it later on. So what exactly are attackers targeting? Mostly it's low-hanging fruit. So it's access points with default names like Netgear, and especially access points with default credentials. So if you're using access points with interesting names like finance, banking, Starbucks, that too can be leveraged in the sense of a man-in-the-middle attack, or rogue AP, and then we can take the other AP offline. The other thing is open access points. So we might be looking for things with no encryption, because if we don't have encryption on the network, what is going to happen is we are on the network to do other things, and we're not being told we can't be there. The other aspect of this is we're looking for you. We want to connect with you. We want to love you. We want to be with you until God calls us home. And if anyone knows me, they know that that statement is what it's from. Inside joke. So now with that, it could be that we are targeting specific network names. Is it a home network? Is it a corporate network? Is it basically, like we said before, interesting names? The other thing is we might be targeting you. What would be interesting about you? There could be quite a few things that's interesting about you. You could be attractive. You could be annoying. You could be interesting. You could be whatever insert obsession that ends up happening in that realm of I need you and want you and have to know all about you. That's within the realm of possibility. Another thing could also be targeted attacks where it might be a news individual or someone who is in the media. There's crazy people out there. There's attacks that are driven by different motives. Anything is possible at this point. If you know if you're being targeted, or if you don't know, drop some comments in the bottom. I'm going to kind of help you with this to understand if you are being targeted and what you need to set up on your network so that you can check to see if anyone's doing a little how you doing stalking. Okay, so in this instance, what we're going to do is we're going to go ahead and we're actually going to scan a Wi-Fi access point that I had set up. We're going to look at the devices that are on it. We're going to do our De-Auths. We're going to capture the packets, and then we're going to crack into it. So let's check out the technical side and how this gets put together. So now we're at the point where we need to put everything together that we've learned in order to perform a wireless attack or an assessment if we've gotten paid to do so. So in this example, we've run ifconfig with the all option, and we are grepping out anything that's wireless, more so the wireless cards that start with WLX. Again, in this case, what we're going to do is we're going to set the wireless card into monitor mode, and we are going to be using this one to search for our traffic. And if we want to get a bit fancy, we are going to pick on and do the discovery on a wireless access point that I put up to make neighbors blush. So in this example, what we're going to do is we're going to scan for local access points, and then if you give it a moment, you'll see everything that pops up. In this instance, what we're going to be looking for is something I commented on LinkedIn on that gave a few people a good laugh. I do tend to do this from time to time just so people in the area look and they're like, what in the hell? So you see we have two network names, so let's do we'll say 10 lines, see if that's good enough. See if we can get enough of information about the network itself. And I want to see if we could get, I don't think it's part of it, but let's do it anyway. No. Alright, so we know we're going to be looking for this wireless access point. We're probably going to pick on this one. We selected our network. We know that is what we are going to target. So I have a laptop, and I also have a desktop system that is associated with this network, and I will be simulating traffic from it. So the next stop that we're going to do is our interface card, which is this one. We are going to throw into monitor mode. So with that started, we will also run Kismet. And once Kismet's up and running, we're going to navigate to it, and then we're going to look for our network. Let's see if we see it. So like I said previously, we are going to focus on the BSSID. One other thing that we're going to focus on is any clients that are associated with it. And here we have 4 clients. So now you can't always go by the MAC addresses of the systems, because if in the event that you have MAC cloaking, where it'll change the MAC address at every association. You really can't say, hey, that's a legitimate box or device. So what we're going to do is from this, we will pick a system pretty much, and then start our De-Auth. I mean, this would be a good system to start with. So let's open up a editor, and inside our text editor, let's note the devices that are in here. One feature that I love, and I coded my own custom software. Don't give me that look, Ramona. So now we have this. It's we'll call it Tuna Smart. And then we have some Samsung devices. And this looks like another computer. Alright, so we pretty much have enough information. I'm probably going to target the Samsung device. Let's get set up to do that. So once everything is pretty much set up, we will be using Airodump-ng with the BSSID of the access point that ends in A8. That is on TAC C, which is channel 1, and we're going to output as AS Handshake with the wireless card that we have that's in Promiscuous mode or monitor mode. So we're going to start this, and then you'll see up here, and I'll highlight this on the screen, when you do obtain a handshake, what's going to end up happening is you're going to see it say that the handshake was obtained. I'm going to show you that in a minute. In the second tab, what we're going to do is we are going to select, I had to do a quick cut, so if the wireless cards don't match up, I've selected a different one. So what we're going to do is boot them off 10,000 times to generate a De-Auth. What we're going to do in this tab is we are going to use Airreplay to De-Auth them 10,000 times, and hopefully we'll be able to get a handshake out of this using the same card that we put in monitor mode that we're using in this segment. So I'm going to let this run, and then once this runs, I'm going to come back and then we'll go through how to test to see if you have a handshake, and I'll show you this in a number of ways. So we've basically run, I think it was like 10,000 packets through, well, 10,000 De-Auth requests to one of the MAC addresses that we will booting off the network. So I'm going to show you a few different ways that you can check to see if in the event you got a handshake that you could potentially use and abuse. Right next to this location up here, you'll see that there's a WEP or Wi-Fi thing that will pop up that'll basically tell you that you have obtained a handshake. Now, if we want, we could also use Tshark like this. And it also helps if I do it the right way. So let's clear this out. And you see nothing came back. So if we also run Aircrack-ng against the handshake, you'll see that no handshakes were formed. Now we're going to go back to the initial screen. So pay attention up here. What I'm going to do is disassociate with the network and reassociate. You could do this in quite a number of ways. Either you could wait it out to see who connects, or if you have the availability of social engineering, you could call them up and tell them your IT that they need to disconnect and reconnect from the internet because there's an issue with bandwidth. And then basically what happens is when I connect to the Wi-Fi, you'll see that the handshake was obtained. So now if we go back and do the same thing again, you'll see we have one handshake. And if we do... oh crap. You'll see that we have EA poll in the packet. So now the next step that we're going to do is we're going to convert this to a format that hashcat can read and crack. So in order to do that, we're going to load this tool here. So now you see it created a hashcat.hc, which is hashcat again. And you see it's in hashcat format. Now the next stop that we're going to do is pretty much put this into hashcat. And we're going to use the following command. And we'll basically use this as the word list. So I'm going to take a brief pause and set this up, and I'm going to show you what that looks like. So I kind of messed up the word list somewhere else, so let's do that now. Let's install hashcat. So now that that's installed, And as you can see, password has been cracked from our crack list. And that's how you go about cracking a password. One thing I do need to point out is that if it is using MAC address randomization, you keep booting off a particular device, it might not work. You might not capture the IV. That's why I suggested calling and potentially social engineering, or you wait until that user comes back online. The last tool we're going to take a look at is WiFite. And now that we see that we have it installed, we're going to run it. And then what we're going to end up doing is when we see the AP that we want to attack, in this case it's the second one, we'll do Control-C, 2, and then we'll wait for a De-Auth to end up taking place. And you'll see that it will successfully grab a De-Auth. And then in a little while you'll see it should actually grab an IV. An IV was obtained. And then from this point, we can go through the crack list and see if we have a password for it. And that would be the last defensive tool that we'll be taking a look at. So, with that said and done, if you have a better or more interesting way that we could go about doing this, again, drop us a comment and we'll gladly talk with you about it. So, on the last stop at dawn, we do need to look at how we can better protect ourselves. Now, this comes from the corporate side. This also comes from the home user side. It could be a mix in between. So the best practices are always check the SSIDs, and if anyone pops up on your network, let's say attack 404 Wi-Fi, and I see attack 404 Wi-Fi come up and there's 2 of them, suspect. Also look at the BSSIDs when you start to do scanning with the tools and utilities that I've demonstrated throughout the series, so you can see if anyone is trying to do some sketchy shit in and around your network. Another thing to look for would be De-Auth attacks, and we're going to take a look at that briefly and how to detect that, so that if you do find things that are going on with your network, you could kind of say that's what's happening, or there might be interference from Wi-Fi access points in the area, which inside it does a very good job of telling you what networks are in the area that you should avoid the channels and stuff like that. So check out that tool. Also, pay attention to disconnects. If you're on the network and everything is fine, and all of a sudden you get booted off, you can't access a share, RDP stops working, you can't print, something is going very wrong, and there's other clients on your network that are having no issue at all, your endpoint might be being targeted in order to offer up that IV so that an attacker can break in. So there's some things on the other side of the coin that you should not do, and you should not solely rely on the SSIDs to connect, and you definitely shouldn't rely on the SSID if there are multiple of the same SSID in the area. Especially if you're at home, more so if you're in a corporate environment, because if, let's say, you work for Dell, and there's Dell 1, 2, 3, 4, 5, and it just keeps going, frequent walkthroughs of that environment to detect and kick out any rogue access points would be beneficial. A lot of organizations may have similarly named SSIDs, so you could walk throughout the environment. That's fine. That's what non-overlapping channels are for. The other aspect is if you're not doing your walkthrough, you're probably going to get caught with your pants down, and you're going to probably get owned pretty hard. Another thing is MAC filtering is not a form of authentication. It is not a form of security. It is security theater. As I've demonstrated, we can change the MAC addresses of the wireless access cards and still access the network. It really doesn't do anything. Lastly, if you have a default setup while you're using bad passwords, you're really doing yourself a disservice at this point. You should be checking if the passwords that you are using are not on any popular breach sites, so that it can't be stuffed into, let's say, a massive password file like I have, and then I go down the list and crack you. A legit attacker who's really looking to get you will exhaust a password file like I have if they are hell-bent on getting you. If you do want to set up additional security, what you can do is radius over VPN with Wi-Fi. This makes it a little bit more difficult to crack into, and it's a little bit better for security and peace of mind. The only downside of this is that you will need to run a server or system or virtualization client that has the availability to handle radius, or buy a product that handles radius on the device itself. So if you know something that we don't, and hey, that got cut off, share with us. Let us know your techniques and how you go about doing things so that we may strive for better security for tomorrow. Yay. So, thank you for tuning in to Attack 404. We appreciate you being here and being a part of the community. If you have any questions, again, like, share, subscribe, comment, do all the stuff, whatever the case is. If you have a follow-up that you want done that we didn't cover or we might not know about, shoot us a line. The worst thing we have to do is maybe research and put it together into a video format. And we'll see you next time.